Hello guys, and welcome back to my YouTube channel. In our previous video we start the topic of merge sort algorithm. We see how we can implement merge sort algorithms, and then take a look at actual algorithm which we then later use to implement merge sort algorithm in C++. We successfully created our function of merge sort, and then we start to build our merge function. So now I will continue this video where I left our last video, or ends our last video. So we have create our first loop for copying data of temp arrays, left and right array, temporary array. Now first loop is created. Now I will create our second loop for auto I is equal auto j is equal to 0 and j is less than sub array 2, and then j plus plus. Now for the right temporary array, jth index is equal to array mid plus 1 plus j. Now for the index of sub array 1 is equal to 0. Initial index of sub array, this is the initial index of our first sub array. Now our index of subarray 2, it will also be equal to 0. Now for the index of our merged array, which is equal to the left now our while loop. Now I will write our while loop code for the merge of temporary arrays back into our left and right arrays. While index of subarray 1 is less than subarray 1, and index of our subarray 2 is less than our subarray 2. Now inside of this while loop I will check if the left array's index is less than or equal to the right array's index. Our left array and then index of our subarray 1 is less than or equal to our right array, and then index of subarray 2. So if this condition is true, then index of merged array will be equal to left array, then the index of subarray 1. And then our increment code of index of subarray 1 will be increment by 1. And now here comes part of our else if left array is not less than or equal to the right array. Index of our merged array will be equal to the right subarray 2. And now our increment for the index of subarray 2 will be 1. It will be incremented by 1. Now I will write the while loop for copying the remaining element of left if there is any. And we have index of subarray 1. We will check if the index of subarray 1 is less than our subarray 1. If it is, then simply the array at the index of merge array will be equal to the left array at the index of subarray 1. Index for subarray 1. Now the while loop for copying the remaining element of our right array if there are available. Index of subarray 2 is less than subarray 2. Index of merge array will be equal to our right array at the index of right subarray 2. Then the increment index of subarray 2 by 1 and index of merge sort by 1. Now here comes our code for deleting these temporary subarrays, the temporary left array, then the deletion of our temporary right array. So our code for merge algorithm or the merge function is complete. Let me just make it small. You can see all of our code. So here is our code for the merge algorithm. Now I will write our code for printing the array. Now the code for our main driver code. We will first initialize an array of integer and give it values of, let's say, 12, 11, 13, 5, 6, 7. Now we'll call our print array function and give it our array and our array size, and then we will call our merge sort function and we'll give it our array at beginning, then the array size and array size -1, the end index. Then we will again call our print array function and we'll give it our array and array size. So our program is completed. Now let's try to run it and check if our array is sorting using merge sort or not. So let's try to run it. We have having an error. So what's the error? Oh yeah, I forget to put semicolon at the end of it. So let's run it again. So you can see our array before the sorting was 12, 11, 13, 5, 6, 7, and after implementing the merge sort function on our array is now 5, 6, 7, 11, 12 and 13. So this is a successful execution for the program which we write for our merge sort algorithm. So now let's take a look at the time complexity of our merge sort algorithm. So the time complexity for merge sort algorithm is omega into n log into n. So sorting array on different machines, merge sort is a recursive algorithm and the time complexity can be expressed as follow. For t of n is equal to 2t into n by 2 plus theta n. So the above recursion can be solved either using recursions or tree method or the master method. It fall in the case 2 of master method, and the solution of recurrence is theta n log n. So the time complexity of merge sort is theta n log n. In all three cases, worst, average and best. As merge sort always divide the array into two halves, it takes linear time to merge two halves. And the space complexity is omega n. In merge sort, all the elements are copied into auxiliary array, so an auxiliary space is required for the merge sort. So is merge sort in place? No, merge sort. In merge sort, the merging step requires extra space to store the element. So second question will be, is merge sort stable? So yes, it is stable. So that's all from today's video. Hope you like our video, and don't forget to like, share and subscribe our channel.